Assalamualaikum warahmatullahi ta'ala wabarakatuh. I am Johanna May White-Tekoken from BSCE 2B, and this is the continuation report of Mr. Jamer Abubakar, the derivatives of vector functions. Just as for real-valued functions, the second derivative of a vector function r is the derivative of r prime, that is, the r is equal to r prime multiplied by its prime. For instance, we have a example here. Function rt is equal to 2 cosine t, sine t, and t. The second derivative of that function is equal to rt is equal to negative 2 cosine t, negative sine t, and 0. We have the differentiation rules. The next theorem shows that the differentiation formulas for the real-valued function have their counterparts for vector-valued function. Suppose u and v are differentiable vector functions, c is a scalar, and f is a real-valued function. Then the number 1, it is called the sum rule. Number 2 and 3, it can be called the scalar multiple rule. Number 4 is a dot product rule. Number 5 is a cross product rule. And number 6 is the chain rule. We have an example 4 here. Show that if absolute value of rt is equal to c, which is a constant, then r prime t is orthogonal to rt for all t. So since rt times rt is equals to absolute value of rt squared and also equals to c squared, which is the c squared is a constant, then we can use the formula 4 in the theorem 3, which gives us 0 is equals to dt, and rt times rt is equals to r prime t times rt plus rt times r prime t is equals to 2r prime t times rt. Thus, r prime t times rt is equal to 0, which says that r prime t is orthogonal to rt. And here the example for solution. Geometrically, this result says that if a curve lies on a sphere with center the origin, then the tangent vector r prime t is always perpendicular to the position vector rt, which you can see in the figure 4. That's all. Shukran and wassalam.